I'm starting a series on the vector database where we will be using different vector database to get the similarity search. In this series, the first one is FAISS is really a simple library that can be used for finding these semantic search between the objects. So for demoing that, I have created a simple demo or FAQ search. So suppose you have certain FAQs and those FAQs you wanted to make it searchable on the basis of symmetric search, not the exact search. User put something related to your FAQ so we can understand which FAQ is actually semantically similar to what the user trying to ask. For making that demo, I have created a REST API endpoint where we can ask the question, and I have created a script with which we can ingest the data to our index. This is the endpoint at the end, FAQ search. This endpoint which we will be having. With this endpoint, we will be able to query what are the similar FAQs we have in the system. The data which we will putting is the question answer, like question is the FAQ and answer of that FAQ which we will be having. So we can put lot many FAQs here. We can even put it into separate file and load it here, or from database we can load. Like we can scrap the FAQs and put it into our index. So for now, we can consider FAISS as a database, vector database, where we will be storing all the embeddings generated by FAQs. So effectively what we are doing, we have these FAQs which we are converting into text embeddings, and those text embedding we are storing into somewhere. So to make it efficient, we are using FAISS. So this provide the index to store your vectors and make it efficient for searching. So the embedder which we are using is the sentence transformation model. We are using the Hugging Face All Mini LM L6V2. This will generate a dense vector, and that dense vector will be stored in FAISS index. So later while doing the query, we have to use the same model, embedding model, and we have to get the embedding. And once we get the embedding of the question, and we already have the embedding in the database, and we have to compare them and find the distance, how close they are. So in the today's demo, we will be using L2 distance, that is the Euclidean distance between the two vectors, to find the similarity between this. I'll show you the flows first, like how exactly is the flow diagram, how what we are trying to do. So there are two flows. One is the ingestion flow. For ingestion flow, we have a FAQ data where we have the question and answer. That FAQ data, we will pass it to sentence transformer model, and that model will create some embeddings that we will store in FAISS vector index, and that will be stored there. FAISS is not actually a full-blown database, it's a library. So you have to manage few things. It is really simple to implement, but scaling this might be little complicated. You need to get the more expertise. So I'll tell you, like here we will be needing a metadata file also, and I'll be showing all of that in this particular demo. So the query flow is once the user write the query, that will again be transformed with the sentence transformer, and that particular embedding which we generated from sentence transformer will be actually given to FAISS, and that will try to find the similarity between two embeddings and will give us the similarity of those, give the result of the similar kind of vectors. Then once we get the vector, we have to look up the data in meta file to understand which particular object that particular vector belongs to. So this is the simple flow which we have. So here one concept which we have to understand is the meta file. So I'll show you like how exactly this looks like. Our flow starts with this, like we have this data. This is FAQ data where we have the questions and few answers. So there so for this particular small demo, I have considered 5 FAQs. So these FAQs are there. So after ingesting it to our FAISS, which is a library, we have to create some kind of metadata file where we have to keep the position of the vector. So I'll show you the meta file. The meta file should look like this. So this will have the question and answer, like whatever you wanted to return, and the vector index. So this is the index where the actual vectors are present. So vectors you won't be able to see in normal text file, and you can actually this vector index will identify at which position this particular index is stored in this FAQ index file. So for the five data which we have stored the position of the vector index. So we have to maintain these metadata FAQ file ourselves. This becomes little bit challenging part to maintain. If you wanted to delete some FAQs, then you have to handle it yourself. So those flows is something which we have to make, but FAISS is having a really good search results, and it's really a small library and powerful library which we can use. So I'll show you the code flow. First, start with the ingestion flow. For ingestion flow, as I have shown you, this is the sample data which we have. I have this in array. You can have it in different file, or you can fetch scrap from somewhere else, and you'll get these data. So this data is passed to this particular function, which is ingest FAQs. If you look into that ingest FAQ function, it will scraping the all the questions, and on the basis of question, it is generating the embeddings with the model which we have here. So if you look into the model is sentence transformer, all mini LM L6V2. With this model, we are generating embeddings, and we are converting into the array of NumPy, and we are appending it to that. And then we are actually trying to get the index if they are already existing index there. At the end, like these embeddings are added to FAISS. And once this is added, we have to maintain the logic of how to maintain the metadata entry that we have to maintain. Like if we are adding some of the entries, some of the new embedding, we have to maintain that particular logic to maintain the entries. For ingestion, we are doing basically three parts. One is the embeddings, then we are putting it to the index itself, and then maintaining the metadata entries. Similarly, if we look into the retrieval flow, for retrieval flow, we have this API FAQ search. In this API, what we are doing, we are getting the question here in our request data. That request data we are embedding as a question embedding, again with the same embedder which we were having earlier. So I'll show you that. So this is the same embedder which we are using. With that, we are getting the embeddings, and then we are using the FAISS function read. This is actually reading the index, and then this search method is actually going there and doing the search, and it is returning the distance and the index. So with this distance and index, we have to go to the metadata.json file which we are maintaining, and we have to find which particularly because this will be returning the index. On the basis of index, we have to get the entry in the metadata JSON file for the particular FAQ. So once we get that, we'll return that particular response. So suppose I have already ingested data. So I'll show you the APIs. For API, I'll be showing you in the Postman. So this is the Postman call which we have, FAQ search. This particular, we have started a FastAPI server. Our server is running on this particular port, and we are using a query of purchase history. And when we are firing this query, it will go to the database and find the relevant vector, and from the meta file metadata.json, it will get us the question and answer. So let's see, like in our actual FAQ, do we what exactly we have stored if you wanted to search that. So this is the file which we have. So we are having the uh, password, purchase history, and we wanted to understand about purchase history. Where can I view my purchase history? This is the question which we have. So on the basis of that, it got the response here. So this is a simple demo of FAISS. So in this series, I'll be exploring multiple vector database. If you like this video, consider subscribing this channel. So until next time, keep learning, keep building. Goodbye.